right. Equation of a line of best fit is also called a regression line. And you can use the line to predict data within your data range. That's called interpolation. And if you predict stuff outside of your data range, that's called extrapolation. So mathematically, if we were going to find that equation of our line of best fit from the one that we drew by eye, we calculated our mean point, which was finding the average of our x values and the average of our y values. Then we drew our line so that it was, most of the points were either a little bit above or a little bit below as best as we could. Then you could calculate the slope if you found another point that went through that line, and then either use y equals mx plus b, or the point slope form y minus y1, mx minus x1, to find your equation. So here we have student's marks, your term mark and final mark. Notice that we're not including this one because that person was absent for their final exam. So here's a scatter plot. Again, title on my graph, relationship between final mark and term mark. Final mark goes on the y-axis, term mark goes on the x-axis. Our mean value was 75, 72, so I've got that listed in there. And then I drew a line where most of the values, some of them were above and some of them were below the line. So now to find an equation of line of best fit, I'm going to look through this and pick another point beside my mean point that this line goes through. The way that I drew my line, I had it go through this point right there. I could have also chosen that point. They both look like they're going through the line. Again, you might get a slightly different slope depending on which point you chose, but that point right there was which one? Let's see. Looks like 88, 85. Is that one of the points? Yes, 88, 85. So this point right here was 88, 85. So using that point and using my mean point, I can calculate my slope. Right? Remember, your slope is rise over run, y2 minus y1 over x2 minus x1. So we would have 85 minus 72 over 88 minus 75, which is 13 over 13, which is 1. So using those points, we would have a slope of 1. Now to find your equation of your line, you have two choices. You can either use y equals mx plus b, or y minus y1 equals mx minus x1. Chances are, in your head, when you think of a line, you probably think of y equals mx plus b first, as far as a formula goes. So I'm going to do that one first, because as far as our equations of our lines go, That's what you're going to think of first. What you know right now is we know the slope. We don't know the b value. But all we have to do is choose one of our points. So if I choose my mean point, where y was 72 and x was 75, subtract 75 on both sides, I'm going to get a b value of -3. And then I could write my equation is going to be y equals x minus 3. If I was using the other formula, again, we know our slope. The y1 and the x1 is just any point. So if we use our mean point here, we would have y, which is the y point, 72, y minus 72, and x minus 75. Then add 72 to both sides. Distribute that one, and you would get y equals x minus 3 as well. So the one, you have to plug in any point to find out what b is. The other one is in a format where you could put in a point and the slope. You don't have to, if you rearrange it, you could find out what b is. But you wouldn't have to rearrange it. You could leave it in that form as well. So now we can figure out that missing value. If the term mark was 80, according to our equation, you would expect that person to get 77 on their exam. And because we're figuring something out within our data range, this would be called interpolation.